Good day, viewers. Welcome again to my channel, Second Math Hub, the solution to your math problems. This is General Mathematics, November-December 2024. Theory, optional question 9. So let's begin with the A. We are to find the equation of the line that passes through a point P with coordinates -5, -4, and perpendicular to a line with the equation 2x minus 3y is equal to 5. So let's quickly represent something. So we have two lines. So I'm naming this line here as line 1, this one here as line 2. Now, we were told that we have to find the equation of the line that passes through the point. So let's say we have a point P with coordinates -5, -4. So we want the equation of this line because this line is passing through this point. And then this line here, line 2, is perpendicular to line 1. And then the equation of line 1 is giving us 2x minus 3y is equal to 5. And what is the relationship between line 1 and line 2? They are perpendicular to each other. So line 1 is perpendicular to line 2. So now, which line are we finding the equation? We are finding the equation of line 2. And basically, to find the equation of the line, there are two things that we need. We need a point on the line and the gradient of the line. So as you can see, we want the equation of line 2. So we need a point on the line. Clearly, we know a point on the line. Point P lies on the line with coordinates -5, -4. What is left here is the gradient of line 2. We don't know the gradient of line 2. So how then do we find the gradient of line 2? First of all, let's find the gradient of line 1. Let's find the gradient of line 1. So to find the gradient of line 1, what do? Let's make y the subject. Let's make y the subject using the equation of line 1. So we have 2x transpose +5 to the left -5 is equal to 3y. So see that the coefficient of y is 3, so we can divide each term by the coefficient of y, which is 3. So we have 2 on 3x minus 5 on 3. This should be equal to 3 will cancel out, leaving y. So y is equal to 2 on 3x minus 5 on 3. So now, what is the gradient of line 1? Gradient of line 1. So I'm representing the gradient of line 1 as M1. So the gradient of line 1 is the coefficient of x after making y the subject. So after making y the subject, what is the coefficient of x? 2 out of 3. So that is the gradient of line 1. Now that we know the gradient of line 1, we should be able to also find the gradient of line 2, since the two lines are perpendicular to each other. So because they are perpendicular to each other, and it means that gradient of line 2, so I'm representing that as M2, the gradient of line 2. So M2 is equal to the negative reciprocal of the gradient of line 1. Let's take note. So to find the gradient of line 2, that should be equal to the negative reciprocal of the gradient of line 1, which is M1. So this should guide us. So with this, can we find M2? Yes, M2 is equal to the negative reciprocal of the gradient of L1, or the gradient of line 1. So for M1, we had 2 on 3. So the reciprocal of 2 on 3 becomes 3 on 2. But we are looking for the negative reciprocal. So now we know the gradient of this line. So now we can find the equation of line 2. You should be able to find the equation of line 2 using a point on line 2. So the point is -5, -4, and then the gradient. This time we are using M2, which is -3 on 2. So to find the equation of a line, we use the formula y minus y1 is equal to m multiplying x minus x1. So where is our y1 and x1? So the x coordinate becomes our x1, and then the y coordinate becomes our y1. So let's do the substitution. So we have y minus y1. y1 is -4, so -4 becomes +4. But for the gradient, we are using the gradient of line 2, which is -3 on 2 multiplying x minus x1 is -5, so -5 becomes +5. Now you see that we have a fraction here. So how do we eliminate the fraction? So we need to multiply each term by the LCM. And the LCM here is 2. So now the first term here is y. So we multiply y by the LCM, multiply the second term by the LCM, then multiply the third term, -3 on 2 x plus 5 by the LCM. Now, can simplify. 2 multiplied by y, you have 2y. 2 multiplied by 4, that is 8. And then at this point, 2 and then 2 will cancel out, giving -3 multiplying x plus 5. So we can expand the bracket. 2y plus 8 is equal to -3 times x minus 3x, and then -3 times 5 minus 15. So we have 2y plus 3x is equal to -15 minus 8. So 2y plus 3x, -15 minus 8, minus 23. So this is the equation of line 2. But basically, alphabetically, x comes before y, so 3x plus 2y is equal to minus 23. So that is the equation of the line. So we can conclude that the equation of the line is 3x plus 2y is equal to minus 23. Okay, so let's look at the B. I read, an observer on the top of a building which is 300 meters high observes that the angles of depression of two beds on the horizontal ground are 55 degrees and 78 degrees respectively. We have to illustrate the information in the diagram, and then we have to calculate correct to two decimal places, the distance between the two beds. So let's quickly draw something. Clearly, we could see that there is a question under 3, that is angle of depression. So let's first of all represent our level ground. So we have our level ground. This is our level ground. And the level ground, we have our building. We have our building. Now we're told that the building is 300 meters high. Now, there is an observer on top of the building. So let's say the observer is here. So we have an observer. And then this observer spotted two beds on the horizontal ground. So let's say we have the first bed here. And then another bed. The second bed. And then this observer again saw that the angles of depression of the two beds. So we know that the angle of depression is the angle below the horizontal eyesight. So this is the eyesight. Eyesight of the observer, the horizontal eyesight. So any angle below the horizontal eyesight is the angle of depression. Okay, so there's the first bed, there's the second bed. So the angle of depression of the first bed was given as 55 degrees. So from the eyesight to the line that connects to the first bed should be 55 degrees. Now also from the same eyesight to the second bed, the angle there measures 78 degrees. So from here to the line that connects the second bed measures 78 degrees. Measures 78 degrees. So with this, we can transform this into a triangle. So how then do we do that? So again, this is our level ground. We have our building, which measures 300 meters high. That is our building. It's 300 meters high. Don't forget that the building is always perpendicular to the ground. So the building is perpendicular to the ground. We have 2 beds on the ground. We have the first bed and then the second bed. We also have our observer at this point. And then we have the eyesight of the observer. So any angle below the eyesight is the angle of depression. Any angle below the eyesight is the angle of depression. So the angle of depression measured from the first bed was 55 degrees. And the angle of depression measured from the second bed was 78 degrees. That is what we have done. We have to calculate correct to 2 decimal places, the distance between the 2 beds. So we are also to calculate the distance between the 2 beds. So now, this is what I'm going to do. I'm going to name the points on the triangle. So I'm naming here as point P, point Q, where the second bed is as point R, and then the first bed as point S. Now, there is something we can do. What is the relationship between angle 55 and then the angle located at point S? 55 and point S. You can see that they are alternating. So alternating angles are angles that are formed from the alphabet Z. Anytime you draw the alphabet Z, there are 2 angles. And these 2 angles alternate with each other. And because they are alternating, they are equal. We know that alternating angles are equal. So if this angle measures 55 degrees, then the angle at S must also measure 55 degrees. Again, we also have another Z, where we have 78. So 78, we are looking at the bigger one. So if here is 78, then this angle must also measure 78 degrees because they are also alternating. And then we know that alternating angles are equal. So that is it. Now the distance from point P to the second bed, I'm naming the distance as X. Measured in meters. The distance between the 2 beds, I'm naming it as Y. Also measured in meters. So from the diagram, you see that there are 2 right angle triangles. The bigger right angle triangle, that is triangle PQS, and the smaller right angle triangle, this one. triangle PQR. So II from the smaller right angle triangle. So from triangle PQR, let's identify the sides of the right angle triangle. There is the acute angle, and we know that in the right angle triangle, where the side facing the acute angle, in this case 78, you are looking at this side, represents the opposite. Don't forget that. And then the longest side is the hypotenuse. And then the other side becomes the adjacent. So this side is the adjacent. Let's recall from SOHCAHTOA. So which of them has opposite and adjacent? So that is TOA. And what does TOA say? TOA says that when you take the tangent of the acute angle, so times 78, this should be equal to the length of the opposite, so which is also the height of the building, 300 meters, divided by the length of the adjacent. So the adjacent of the smaller right angle triangle is x. So let's solve for x. We have times 78 is equal to 300 on x. Times 78 can also be written as times 78 on 1. So at this point, we can cross multiply. So times 78 times x, we have x times 78, and then 1 times 300, we have 300. We are looking for x. So we can divide both sides by times 78. So we have x is equal to 300 divided by times 78. So for now, I'm correcting it to 3 decimal places, 63.767 to 3 decimal places for now. But that is not the final answer. That is not the final answer. So to 3 decimal places. So let me get the space here. Now, can we also look at the bigger triangle, the bigger right angle triangle? So from triangle, so the bigger one, triangle PQS. So can we also identify the side of the bigger right angle triangle? So this side represents the hypotenuse, the longest side. 55 degrees is facing the height of the building. So this side also becomes the opposite. And then obviously the other side becomes the adjacent. So from SOHCAHTOA, we see that TOA has opposite and adjacent. And what does TOA says? TOA says that the tan of the acute angle, in this case tan 55, must be equal to the length of the opposite, which is the height of the building, 300, divided by the length of the adjacent. At this time, what is the length of the adjacent? The adjacent has been divided into two. One part measuring x and the other measuring y. So the full length of the adjacent with respect to triangle PQS is x plus y. So we have tan 55 is equal to 300 divided by x plus y. So tan 55 is the same as tan 55 on 1. So we can cross multiply. So we have tan 55 multiplied by x plus y. So we have x plus y tan 55. And this should be equal to 1 multiplied by 300. So 300. So x plus y multiplied by tan 55 is equal to 300. So we can divide both sides by tan 55. So tan 55 will cancel out, leaving x plus y is equal to 300 divided by tan 55. So x plus y is equal to, so what is 300 divided by tan 55? 300 divided by tan 55. Okay, so also to 2 decimal places, 210.062. We are looking for y because y is the distance between the two bits. But what is x? We know that x is 63.767. So let's substitute x into this equation. So in place of x, we have 63.767 plus y is equal to 210.062. So let's make y the subject. We have y is equal to 210.062 minus 63.767. So what is y? 210.062 minus 63.767. 146.295. But don't forget that we have to correct our answer to 2 decimal places. So to 2 decimal places, we have 146 point, so we can round 5 up, 0.30. Don't forget the unit in meters. So what is the conclusion? What is the conclusion? The distance between the two beds is 146.30 meters. I think this was a very nice and interesting question. I hope you enjoyed this episode. Please don't forget to subscribe. Your comments are highly welcome. And then don't also forget to share the link to your colleagues on other platforms for them to also benefit. Thanks for watching. See you next time.